So, um, I am the Executive Director of the North Shore Mosquito Abatement District, and today I'm going to talk about wide area larviciding with a buffalo turbine and VectoLex WDG. Typically, you see this kind of larviciding with VectoBac WDG, especially for container mosquitoes. And we thought it would be interesting to try this for floodwater habitat, especially here in our kind of unique district. So in case you're not familiar with where the North Shore Mosquito Abatement District is, we're located in northeastern Cook County, and that's in northeastern Illinois. And this is actually Chicago. We're a suburb community of Chicago. We range from really dense urban all the way to suburban habitat. Through the center of the district runs the the north branch of the Chicago River. And on either side of the river are extensive floodplain and green areas that have all been preserved as parks. And you can see that in the picture in the top left. All that green space can all flood. It's all along a river. So if you know anything about Chicago, it's notorious for rainwater and floodwater issues, has been for a long time. And in the early spring, these areas will fill up. You'll see in the center pictures, we treat a lot of this by manually with a backpack. Our staff walk through this deep floodwater treating with either BTI or Bacillus sphaericus. And the picture at the top shows how dense a lot of this habitat can be. It can be really impenetrable. Typically, we would treat this with a vortex. That's the picture on the right. A lot of these green spaces have running trails through them, and so we would take a truck and kind of shoot granular material into the woods, hoping to get enough into a lot of this floodwater. And as you can imagine, it works better in some places than in others. The vortex is a great tool, but some of these floodwater areas are quite large. So this is a problem for us because we only have a 4 or 5 days maybe between a heavy rain event and when mosquitoes will emerge. On the right is a band of fourth-end stars and pupae just ready to ruin a barbecue somewhere. And this is extremely common in all our flooded areas to have just enormous broods of vexins. And so the key for us is how do we get through all of our floodwater in a really short timetable after a rain event with really, limited staff. We have 12 seasonal staff members generally and 7 full-time members. So we took some cues from the Zika response in Miami and some of the other ways that VectoBac WDG are used in Florida with the buffalo turbine, and thought, well, maybe we could do this with VectoLex and sphaericus. And so we set out to kind of recreate this method for our floodwater areas. So to do this, the first thing you need is a buffalo turbine. We were fortunate to get one from Macon Mosquito Abatement District in Southern Illinois. They had no use for it anymore, and they basically gave it to us. You need a rotary atomizer. These are typically used in aerial application of adulticides or larvicides. And then Micronair also sells a adapter, which is the picture on the top right. And so it's pretty easy to retrofit a Micronair onto a buffalo turbine. Micronair has this all set up and ready to go. And then of course on the bottom right is a VectoLex WDG, and WDG means water dispersible granules. So this is kind of like a pancake mix that you mix with water. And then is basically a liquid larvicide. So there's a few important things to use a turbine in this way. You have to set up the correct flow rate. You have to have the correct blade size for this Micronair. Basically, the rotary atomizer sits in the airflow and spins based on the blade size, and the blade angle will control how fast the Micronair spins, which controls the droplets that come out of the turbine. And so it's important that everything is set up just right. The right flow rate, the right blade size, the right blade angle, the right concentration, the right volume. It sounds complicated, but Leanne makes it so easy. It's really not hard at all. So Micronair has a manual which shows how to kind of organize this rotary atomizer so that it'll give you the correct droplet distribution. We know we wanted droplets at about 150 microns, and the figure on the right shows that we should want a rotational speed of about 6,000 RPM. And then the figure on the center there, to get 6,000 RPM at about 140 miles per hour, which is the wind speed coming out of the turbine, you want about a 55-degree blade angle, and that gets you right where you need to be to make this work. Then you have to calibrate, mix and calibrate the material. We calibrated this for about 3.2 gallons per minute at 50 PSI. And at 10 miles an hour, this will apply exactly, or just about, a half a pound of VectoLex per acre. So that's our final application rate when everything is calibrated and set up. This is a beautiful spring day in Chicago. It was a gorgeous day. And we set up a bunch of chrome coat cards perpendicular to our Buffalo turbine and mixed in red food coloring. This is pretty standard with Buffalo turbine or other kinds of calibrations. Whoops. And we basically were able to count the number of droplets and the size of the droplets to determine how far this material went and what its droplet distribution looked like. And so after we did this, we found that we got pretty decent coverage out to about 300 feet, probably got even further than 300 feet. We had a volume median diameter of about 150 microns. And then our droplet density, of course, was highest between like 100 and 200 feet, but stayed pretty good all the way out to 300 feet. So it's important that the droplets are the right size, because if they're too big, they won't go very far and all your material will end up in the first 50 or 100 feet. If the droplets are too small, they'll go too far and you'll have too thin distribution in the area you're trying to treat. So trying to find a happy medium is important, where you have enough droplets that land closely and enough droplets that land 300 or 400 feet out to get control throughout the entire area. The next step was to test this operationally to see how this worked. So we picked an area along a jogging path where we had a treatment site and a control site. And both these sites are about an acre in size, and they're notorious for being really productive for mosquitoes. And they just harass people as they're running through or biking through, whatever. The goal was to apply about a half a pound an acre. This is a picture of one of those floodwater sites. Believe it or not, in that brush is about a foot of water. It's just incredibly dense and almost impossible to get to with a backpack. We used GIS to pick 10 random points per week, and then we went out and sampled each of those random points. The only way we figured to really assess statistically the effect that our treatment had on larval mosquito populations was to do a truly randomized design. So there is software freely available that'll give you random points within a polygon. And that's what we used. It feels a little stupid to go where there's not mosquitoes and sample, but that's the only way to do it. If you're always going to where the larval mosquitoes are, then you're really biasing your sample. So it was important to have randomized points. So we would dip a single dip and then count how many larvae were in the dip. And then we sampled these for 7 weeks, 10 dips per site. And this is what we found after one treatment. On day 0 or week 0, which would be the time of the treatment, there was really no statistical difference whatsoever between our treatment and our control site. And then in the week following, there was already a statistical difference. Our treatment site had basically 0 mosquitoes in week 1, 0 in week 2, and then maybe just 1 or 2 in week 3. And this lasted for a total of 6 weeks until we ended the experiment. So we started early with this, and we didn't see mosquitoes return to the treatment site really for the whole season. I think they just were that pretty much done for a while. And every week here was statistically significant, except for the very first week. More district-wide results. In 2018, before we had the turbine, we were able to do maybe 200 of these acres manually by backpack and by vortex. With the turbine, we were able to increase that dramatically to maybe 11 or 1,200 acres treated, and which was like basically a five-fold increase in the amount of acres we're able to treat. The figure on the right shows the average weekly precipitation on the x-axis, and then the average Aedes vexans mosquitoes per night on the y-axis. And you can see roughly that there's a positive correlation that when you have more precipitation, you're going to have more mosquitoes, of course. The red dots are 2019, and that line is essentially completely horizontal, which basically says that despite a lot of precipitation in 2019, I think we had the wettest May ever in history, we just did not see big broods of mosquitoes. Once we employed this method, and we're able to quickly treat the areas we needed treated. This is the first year that there's really not a lack of correlation, that there's really a lack of correlation. Every other year that we've looked at, and we have data going back quite a ways, there's almost always a positive correlation between precipitation and mosquitoes. So this is some positive evidence that if you can go out and find where the mosquitoes are and treat them timely, it will make a difference over, at least over our 70 square miles. So along the way, we came up with some other methods for mixing VectoLex. Mixing is lots of different ways to do this, but we found a stainless steel dewatering pump, the biggest one you can get that's still electric. I think it was like a 3/4 horsepower or something. And we actually just drop this into our tank, and then we'll put a funnel on top and pour the VectoLex into the funnel and let it kind of just pour into the tank and mix on its own with this dewatering pump. The advantages for us are we don't have to empty any hoses with excess material. We don't have to rinse any hoses. All we have to do is lift the dewatering pump out and put it in a bucket. We have our district is kind of in an urban area, and dealing with rinsate is not really an easy thing for us to do, and we don't have a lot of room. So this was a really great compact solution for effectively mixing this material. It worked quite well. So I would highly recommend exploring something like this if you're interested in using any of these WDGs. And then finally, on the left is our district and our Buffalo turbine, and the right was the actual treatment that we did. You can barely see it on a bright sunny day. We did this first thing in the morning, but it was very effective. So thank you for listening to my presentation, and I'll be a part of the panel later if you have questions you want to ask.
Awesome. Thank you so much, Mark. We definitely do have a couple questions for you, but I am going to hit you with one real quick just because we do have a minute. What kind of wind direction and speed did you experience, I'm assuming, during those types of applications? And was there any time that you applied without the ideal wind conditions?
You know, I think we had, during this experiment, we had just a few miles an hour. It would have been better to have a little more wind, but it seemed to be effective. We've been applying first thing in the morning. Typically this is done at night, but here, especially in the spring, we've had good results applying in the morning. We haven't really had the need to go at night when the atmosphere is different. So I think because we're further north and because the spring is cool and the ground can be cool, we can get away with earlier applications in the day. Wind speed, and you know, if it gets too windy, I'm not sure that it really does much. It just moves sideways. You may get some control beside the truck, but a lot of those smaller drops just move sideways. So if it's above, I don't know, 8 or 10 miles an hour, we won't bother.